Okay, you guys, here we go with this week's video. As I mentioned in class on Thursday, I want those presentation evaluations from each of you. I've gotten them from 4 of you. So the ones that I haven't gotten them from, if you would please do your own self-evaluation. You'll have to go back to last week's video and then take a look at that. Make sure you've printed out that evaluation form and then score yourself. And then I'll gather those up from you in class on Thursday. Then I hope you enjoyed taking a look at the goldfish blood circulation. I know that was kind of quick, so let me show you just another YouTube shot of that. I didn't take this video, but I just wanted you to see that. Let's talk about what we did in class on Thursday. We really collected 2 different sets of data. We had a goldfish hanging out in the high nitrate water, and then we had a goldfish hanging out in the water that we changed the temperature of. I'm going to just ignore the nitrogen water bit for now because that was only one data source. We only did it one time. However, we can compare that against the temperature of the water data once we've done something with that water or that data. If you don't have your notebooks, make sure you go get those. That's always an assignment, so make sure you have those. So you have a data table that you've created, and in that data table you've got temperature and then you've got breaths, the number of breaths that the fish took during 1 minute. What we're going to do is to build a graph of that data, but I have a question for you. The question is, we have 2 variables that we measured. One was temperature and one was breaths. Hopefully you know what a graph looks like. That's that figure on the right-hand side. The line that goes horizontal on the bottom is called the x-axis. The one that goes vertical up the side is called the y-axis. One of those variables has to go on the x-axis and the other one has to go on the y-axis. So the question is, which variable goes where and why? I want you to pause the video and I want you to write in your notebook where you think the breaths go on the graph and where the temperature goes on the graph and why they go there. So hit pause, do that, and then I'll go on to the next slide. So now that you have made a guess as to where the variables go, let me introduce you to a couple of terms. The first term is the independent variable. The independent variable is that variable that stands alone all by itself. The other variable that we have is called the dependent variable. And look at the middle of this graphic. It says one influences change in the other. So the independent variable is the variable that influences change in the dependent variable. So now that we know that, what affected change on the other? Did the breaths affect the change on the temperature, or did the temperature affect change on the number of breaths? Once you know that, you now know which is the independent variable and which is the dependent variable. Again, if you want to pause the video and rework your first answer, do it and then tell me why you chose whichever one you did for the independent and why you chose the other one as the dependent. Another term that we sometimes use in place of or alongside of independent and dependent are the terms manipulated and responding. And I use the term manipulated because that's the variable that we, as the investigator, are manipulating, and then that manipulation causes change in the responding variable. So influences change kind of means the same as responding. Now that I've gone through both of these slides, you should be able to tell me which variable we manipulated, all right, and which variable responded to our manipulation. Now that we have that, you should know that the temperature goes on the x-axis because it is the independent variable. It is the one that causes change to result in the dependent variable, which in this case is the number of breaths. So as we change the temperature of the water, the number of breaths changed. Now, this is how we would set up our graph. When you go back to the page on the website, you'll be able to actually print a page that has graph. That's a graph paper page. Go ahead and print that because you're going to create a graph, and then I'll have you put that graph in your science notebooks. So what you need to do is remember that where those two lines come together right here, that's the 0 point, and then to the right hand side on the x-axis the numbers get bigger, and then as you go up on the y-axis the numbers also get bigger. So that's your 0 point. So look at the highest temperature that you have, kind of spread things out along the x-axis, and then you're going to do the same thing along the number of breaths. So you start with 0 down where those two lines come together. And what's the greatest number of breaths that you have? And mark your lines. When you mark a graph, you mark the lines and not the spaces. So you mark the line and not the space. So the first line is 0. Maybe the next one is 2. 2, 4, 6, 8, 10, 12. Or maybe that's not going to get you high enough, so then you go by 5s. 5, 10, 15, 20, 25, 30, 35, 40. But choose a spacing between each line, in terms of numbers, that allows you to spread the numbers out as far as you can on your graph paper. Same thing across the bottom. Once you've done that, you match up the temperature and the breath. So if the temperature was 5 degrees, go up the y-axis until you hit whatever number of breaths it was and put a dot at that spot. Do the same thing with the temperature at 10 degrees and at 15 degrees. And that's the way you build that graph. So everybody make their graph. Once you've done the graph, you're going to see you have some points on there. We have to decide what to do with those points. And when you just look at the data that you've got, the dots that you've got, you ask yourself one of 3 questions. If I were to connect those dots, would they produce a smooth curved line? So it could be smooth like this way, it could go this way, it could do something like that. The question is, does it produce a smooth curved line? So that's choice number 1. Choice number 2 is, do they line up in such a way that you can create a straight line when you connect all those dots? If it's not straight, then that may not be, the best choice. Or is it random? Does it show some kind of a pattern, but is it basically random? So you decide, is it best to connect those dots through smooth curved line, through a straight line, or should we not connect them at all and just leave them random? We'll talk in class about the best thing to do with this data that we have. The next thing I want you to do is look at that graph, because graphs always tell a story. I want you to begin to tell a story about what the graph is saying. And when you tell that story, you are going to tell the story from the evidence that's on your graph. You've got evidence of the temperature, you've got evidence of the number of breaths. In science, we call this arguing from evidence. It's not the kind of arguing that you have with your parents at times, or with your little brother or older sister or something like that. This is argumentation that you go through a process where you are making a claim that you believe is true, and it's based on some evidence. So argumentation in science is not saying that, well, I think that pine trees are the prettiest. That's not arguing. But you could look at a pine tree and say something like, over the last 5 years, this pine tree has only grown, 14 centimeters. And then you have data from 5 years ago, 4 years ago, 3, 2, 1. And so then you have evidence that provides support for the claim that you're making. That's how you argue in science, and argue from evidence. So your job, when you come to class on Thursday, I'm going to ask you to tell the story of your graph, and while doing that, you are arguing from the evidence that you have gathered about the temperature of the water and then what happens to the breaths of a fish, the goldfish. You can also go beyond that and do some research on your own. One of the things that I mentioned in class on Thursday was that goldfish are cold-blooded. you might want to do a little bit of research on the internet and find out what that means for an organism to be cold-blooded, and to see if you can't find more evidence that supports the argument that you are presenting about why the number of breaths did what they did as the temperature of the water changed. Okay? So have fun with that, and I'll see you guys in class on Thursday. Thanks.